So hello guys, with the name of God Ram Ram. So in Meesho A always hard, interesting, unseen DSA problems keep on coming. You can check our previous Meesho A videos. You have seen that they are always asking tree based problems, and yet again in Meesho A tree based problem was asked. Okay. Now this problem is so difficult that you are not going to understand this session by Kumar K, me, unless you complete the maths course from our prerequisite warm-up DSA plus OA plus CP course and the tree course. So you need to visit this warm-up course, and once you have visited this warm-up course, you have to complete the maths section fully, the sieve of Eratosthenes part also, and the prime number part, okay? And the tree part you need to complete till the end. So guys, react with emojis giving me the confirmation that you guys have done it and you have enjoyed it and you understand the basic maths and tree concepts. Okay. So we do not have the exact image of the problem. All we know is the words of the student who was talking about this problem. That said, this problem was asked to me. So this problem we have reframed, okay, and we have put this image here. The actual image the student could not take in the exam, as far as I know about it. Now, what is the understanding of the problem? The understanding of the problem is that a tree is given to you. The most important understanding regarding the problem is that a tree is given to you. So let me write here about the understanding. A tree of n nodes is given to you. A tree of n nodes is given to you. What a pleasure. Find the number of paths. Find the number of valid paths. Find the number of valid paths I comma j such that in the path from I to j only one node has prime number value. So that's it guys. That's it. For this problem, this is the question given to you. Okay. So, do you even understand about trees and what is the path on the tree and things like that? For example, you guys know that tree always looks like this, right? We can assume the root node to be the topmost node, but tree can look like anything. There can be multiple nodes, right? Let's say this is the root node, okay? And we generally in our problem assume that the root is node number one. That is just the assumption. In this question, if you check, there is no root defined, and the speciality of the tree is that you can just enjoy, like, how many nodes are there in the tree. N nodes are there, so here n is what, 1 2 3 4 5 6 7 8 9 10 11 12. So there are 12 nodes, right? 1 2 3 4 5 6 7 8 9 10 11 12. So guys, if there are 12 nodes without counting, can you tell me how many edges will be there in this tree? These are the special properties of trees, so just asking you people. So tell me in the Google chat how many edges will be there in the tree of node 12. It is a simple connected tree, undirected. 11. Okay, good. So there are 11 edges. Now guys, what is a path? What is a path on the tree? Let's say this is node I and this is node J. So what is the path from I to J? Well, the path from I to J will look like this, right? From this node, you will first go up, then you will again go up, then you will go down like this, then you will take this branch, and then you will reach J. So can you see this path of how many edges? How many edges are there in this path from this node I to this node J? How many red color edges are there? Write in the Google chat. From node I to node J, how many edges? 4 edges are there. So guys, there is one more property of the tree. What is that property? If you try to make any path from node I to node J, only a single path is possible. Only a single path is possible. Can you see that here there is only a single path? That path is you go like this and then you come back like this. There are no multiple ways to reach I to J. If you are visiting each edge and each node exactly one time only to go from I to J. Like there is only a single shortest path from I to J. That is the definition of a tree. That if you start traveling from node I to node J, if you start traveling from, let's say, node I to node J, okay, this is your node I and this is your node J. Then if you try to make up a path from node I to node J like this, there will only be a single path. There cannot be multiple paths which will lead you to node I to node J. And I am talking about the shortest paths. And this question also meant the shortest paths from I to J. How many shortest paths are there from I to J? So from I to J, there is only one shortest path. In tree, you should know that in general, from I to J, there is only one path possible. That is the shortest path, and only one path is possible. Multiple paths are never there. Multiple paths can exist only if it is a graph with cycles. For example, see, if this is I, this is J, there are two paths, right? You can go like this also and go like this also. But this is not a tree. Tree cannot have four nodes and four edges. Tree will look like something like this. See. So if this is I and this is J, there will only be one path. If there are two paths, means there is a cycle. It's not a tree. Okay. So tell me, do you understand this concept, guys? That in tree from node I to node J, there can only be one path. One simple path. In competitive programming and in OA, we call it as simple path. Simple path means you just travel from I to J and you just visit each node one time and each edge at most one time, each node at most one time. That's it. You are not allowed to visit any node or any edge multiple times. That is called as a simple path. And I really love simple paths. But in code forces problem, many times there are not simple paths. There are some complicated paths. And actually complicated paths makes the problem even easier in many cases. Simple paths are, which is given here, simple paths problems are actually the most difficult. Name is simple, but problem is going to be difficult of simple path. Okay. So yeah, that's it. So guys, now how to solve the problem? Well, a brute force method is possible, right? Like there is a O of n cube brute force method. Before we go to that, guys, it's we should decompose this problem. Decomposition is very important. Currently, we are not focusing on the decomposition. Decomposition means why they have added this prime number thing. Did you ever try to think that the problem setter, why did he add that prime number thing? If you try to think about it, he just want to check your sieve knowledge. He just want to see that if a number is given, do you know how to know it is a prime number or not? So you can convert this problem to white node black node problem, right? White node black node problem. So this decomposition is very important. Mark all nodes whose value is prime as black and other nodes as white. Guys, who agrees with my decomposition here? We do not need to do so much tam jam na. Convert it to a simple tree where each node is just white or black. Kala matlab wo prime number hai. If it is not black, then it's not a prime number. So simple. Like I am giving you guys a tree. I want you guys to draw it on your paper and send in the pro group the tree with the white and black node naming. Okay. So I am giving you a tree and I'm going to give you the numbers also. You guys have to convert it into white black tree. So we will solve on white black tree. We will not solve on the original tree with the numbers. 1, 2, 3, 4, 5, 81. Or let's say 1, or let's say 2. Let me write here, write it as 2. Or let's say 1, 2, 3, 4, 5, 3. Convert it to white black tree immediately. So I will be denoting the white black stuff using something else. You guys have to denote it using something else. Clear? Yeah, so let me check if everything is all right. Yeah, good. So let's convert it to white black tree so you'll understand that um, you will understand that one is not a prime number, right? So this is a white node. This is a black node. Two is prime number. This is a black node. This is a black node. This is again a black node, and this, okay. This is, sorry, I wrote incorrectly. This is three, so this is black. This is also black. This is also black, and this is white node. So guys, I have converted the question to white nodes and black nodes. Now guys, it is given in the input that all the values, okay, all tree values, like it was given in the problem itself. If I talk about the constraints, we do not have the pick about it, but the constraint is that the number of nodes in the tree will always be less than equal to 10 raised to 5. Obviously, 1, 2, 3, 4, 5. And coming to the, see, you know about n. Now coming to the values can be 1, 2, 3, 4, 5, 6. So, is there any algorithm? Acha, first of all, you all understand how to convert this tree to white, black, black, white, black, black, black node. If the number is, if the number is like, let's say if the number is non-prime white, if the number is prime black, so you understand how to convert it like that, right? You will just write a if condition, right? Travel all the nodes of the tree. If the number is prime, color that as white, put it in some other array. The color of this node is white. If it is, sorry, if it is not prime, the color of that node is white. If it is prime, the color is black. Write yes or something and let me know, do you understand this algorithm to convert the whole tree into white and black nodes, because there are only two type of numbers, prime number and non-prime number. Clear? Now guys, tell me, what algorithm will you use to know in O of one time if a number is prime or not? When I travel this number, how will you check if 3 is prime or not? Don't tell me that you will calculate all the factors of 3. No, 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 no. You will do pre-calculation of sieve of Eratosthenes. Sieve of Eratosthenes will pre-calculate all the prime numbers from 1 to 10 raised to 6. And you will store these prime numbers in a hash map. The hash map of I, if hash map of I is equal to 1, means I is a prime number. So first you store all the prime numbers from 1 to 10 raised to 6 in a hash map. Hash map will store the number with its frequency in a coming one time. So if hash map of I is 1, it's prime, assign black color. If hash map of I is 0, it's not prime, assign white color. But how to store all the prime numbers from 1 to 10 raised to 6? Well, that is sieve of Eratosthenes. For that, you need to go to my brilliant math course, our brilliant math course, not just mine. I am because of my students. So you go to the maths course and you please study this prime factor things and sieve of Eratosthenes, and you will understand how to pre-calculate using sieve of Eratosthenes. Now, people who know that sieve of Eratosthenes can generate all prime numbers from 1 to 10 raised to 6, which you can store and put in a hash map, and then easily check if a number is prime or not. If you know this concept, write yes. If you don't know this concept, write no. Hopefully, most people write yes only because if you are in the pro batch, I do think you must be knowing that. I'm very sure about it. So it's very easy, right? Like sieve of Eratosthenes. Obviously, this is advanced batch session, so you should know these things already. Eratosthenes. Yeah. Pre-calculation. Okay. So you will do the pre-calculation. It will take O of D of log of D, where D will be 10 raised to 6. Okay, so these things are clear to you people, right? You're enjoying it. Okay, 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 okay. Very nice. Very nice to see you all. Yeah, so yeah, nice to see Karandeep Singh also. Now guys, listen to me very carefully. Karandeep Singh is the CP mentor. I did not expect him to attend my OA session. I don't know how he has joined. Anyways, guys, going back to the session, going back. Okay. So, guys, you understand that C of Eratosthenes. See, everyone needs to study sometimes. You understand that, right? C of Eratosthenes, the pre-calculation O of D log D, D is 10 raised to 6. Okay. So this thing you understand, right? I also understand. And using this, immediately I know what to do. Now, guys, what is the new problem? Tell me now, what is the reframing? Reframing of the problem is find the number of paths I comma j such that react with emojis if you will be able to tell me what is the new question coming up. Once this process is done, our tree has only white node and black node. Now what we have to find? The number of paths I comma j such that exactly one node in that path is of which color? I leave that up to you. Tell me, guys, what will be the reframing? We have to find the number of paths I comma j in the new tree such that in the new tree such that exactly one node on the path is of black color. That's it, guys. Exactly one node in the path should be of black color. Do you guys understand this? That is not going to work, unfortunately, Aditya Shandilya. Number of paths that contain only one black node. Yes. That is not going to work because you have to take care of black and white both. We cannot break them. Okay, we cannot break them. If we break them, black will just get isolated from white. Then what will you do? Will you dance after that? Black has been isolated from white. Now what will you do? No, you cannot isolate them. Okay. So listen. Basically, we cannot dance after separating black with white. Nothing is happening. We are not knowing the number of paths, right? So if the question was that, yeah, but Aditya Shandile, great job, guys. Like while doing this question, I realized that if the question was something else, let's put it as the homework question, okay? Like a new question is coming up. Very nice, very nice. This is the simplest version of this problem. If the question was, I I think you guys can think and solve it on your own. I will not tell the main solution. If the question was the path I comma j is valid, the path I comma j is valid if and only if all nodes on the path are of black color. React with emoji if some people realize that this is super easy problem. If only like if you had to count only those paths where all the nodes are black color, then you can just separate the white nodes and black nodes, right? Break all the edges between white and black. Now you just have connected component of black nodes. Now let's say this is a tree, like this is a super easy version. Let's say this is white, this is white, this is black, this is black, this is black, right? You only want those paths where all the paths are having only black color. Let's say this was the question. So wherever there's an edge between white and black, you break it. Now you only consider the connected components which you've got of black color. How many nodes are there? 3. So the number of paths will be what? 3 into 3 minus 1 by 2. Because each node will be making path with someone else, right? So I comma j, if there are n nodes, n into n minus 1 by 2 distinct pairs, right? This would be a great problem, Aditya Shandila. We discussed concept like that, right? So guys, this is the homework. Make sure you try to solve it, okay? Make sure you try to solve it. This is very easy. You guys know these things now or you don't know? Did anyone understand some easy version which I discussed recently? Or you guys did not understand? That if the question was asking you only to count the number of paths where only black nodes, like all the nodes in the path are black, this was very easy problem. Tell me something about that in the Google chat, yes or something like that. Did you understand? Because you need to understand the easy version also, right? Okay, you understood. Okay, good. Nice. Good. Great. Ayan, did you understand? Need to know from Ayan also. Okay, good. So now let's go back to the harder version. Okay. So there is some problem in our life. Like there is not actual problem. The problem is that the question is this: that we want to know the paths. So that exactly one node on the path is of black color. Oh, so painful, so painful. Ah, exactly one node on the path is black color. Okay. Mm-hmm. Okay, okay. Things are clear in my head. It must be clear in other people's head also. You need to go very deep. To become successful, you need to go very deep. So you need to find the number of paths I, comma j in the new tree such that exactly one node on the path is of black color. So what to do, how to do. Here, the thing is that I knew the solution, but I knew that writing code is a big task. So when Atul asked me, this was going on in my brain. So is there Atul in the meeting? Hmm. अतुल 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 नहीं है क्या अच्छा है क्या if Atul was not there it would be a nice joke that Atul was the person who asked the problem and he is only not there in the meeting. Okay, Atul is there by the way, so we better be serious about it. And Atul, this is Meesho a problem, okay? Don't change the words, just remember that. Okay, yeah, so just focus here. The actual reality, Atul thinks this is some other OA problem, which might be true, but as far as I know this is Meesho a problem. So now, guys, what I did in this case is that I just focused on a particular black node. What if there is only one black node in the whole tree? We always go for the easiest cases, right? So let's say that black node, let us say node I is black and C1, C2, C3, C4, C5 are the children or parent of node I. That's it. So guys, let's take some easy case, right? Like I will ask you the like everything will be clear to you in front of your eyes only. I'm not going to do anything very different or out of the ordinary. So life is so interesting. I really love it. Let's say, see, I also know no one is going to teach you problems like this. So you need to fully enjoy. Let's say this is a black node. Okay, this is a black node. I can feel it. Okay, good. Nice. Now what to do? So this is a black node. Okay, and rest all the nodes are white. Okay, like this is black. This is white. Let's say it's parent. Like if I'm making some vertical line, they are the parents. Okay, white, and this is also like white only. Or let's say only one node above is there, and that is white. Okay, this is white, and let's say one more white. So two nodes above there are white, three are there below. Let's say this is also there, white, white, and let's say there is one more branch here, white, white, white. So now guys, what do you think about the paths which will happen? If I try to make it even easier, let's say it is like this only, okay? Let's make it even easier. Let's say this is the white node. Now, how many paths are possible such that the trick is that you just focus on the subtree sizes, right? For this black node, this is let's say C1 child. This is C2 child. This is C3 child. I have taught you the size of the subtree concept, right? Size of subtree. So how many nodes are there here? Two. How many nodes are there in this subtree branch? Two. How many nodes are there in this subtree branch? Two. So guys, if I try to make array of them, what it will be? 2, 2, 2. Okay, sir. Okay, I can see something going on. Cooking. Something is cooking. And that thing is that, let's say we have no parent. Like, we do have parents. Parents are very important. But for this case, let's say only like there is this black node and then all are just white. Then the answer would be, you know what? You would just be, I think you can see what I can see. Whatever are the children's subtree sizes now, which are all white, all white, all white, just put them in some array. 2, 2, 2, 2, 2. Now, guys, do you agree that both these nodes can make valid pair with this white? Both of these can make valid pair with this white, this white. See, if you pick up this white, he can just go and make relationship with this white. This path will have only one black now. This white can make relationship with this white. This path will also have only one will have only exactly one black node, right? And similarly, this can go and make relationship with this. This can go make relationship with this. Similarly, this can go make relationship with this. This can go make relationship with this. So, guys, this guy can make relationship with this also and this also. So, total how many relationships? Like, it will be what? 2 into, what is the total here? 4. 2 into 2 plus 2. These many relationships can be formed if all the paths are starting from C1 subtree. Now what? How to count the paths which are starting from C2 subtree? The path starting here, they can make relationship only with this part, right? So for them, the answer will come as this number 2, and what is the leftover? 2. Total answer is 2 into 2 into 2 plus 2 plus 2 into 2. Now, who understood this will write great, sir, and who did not understand will write nothing. Okay. So, what I'm trying to show is that, guys, these are the only paths where the path has only one black node now, because see, this subtree has two nodes, this subtree has two nodes, this subtree has two nodes. So, I make their array like this: 2, 2, 2. Fair, fair, fair. Interesting. I can take this guy and make its relationship with these four other people, right? If you try to make its relationship with these four other people, all those paths will have only one black node. You can see that in front of your eyes, baby. And same will happen if I take this node and make relationship with these other four nodes, which are outside now of the other children subtrees. Not this white with this white. Then it will be wrong now, because there is no black node in this. So basically, for these two guys, they can just marry the rest of the suffix. So 2 into 2 plus 2. Now, but we, okay, so इसका मतलब मालूम है क्या हो गया? Let's say this is C1, C2, C3. So when you write 2 into 2 plus 2, you know what is happening? You have counted all the paths which are going from C1 subtree to C2 subtree, C1 subtree to C3 subtree. So this to this and this to this has been calculated. Now what? Now C2 to C3 subtree paths are still pending. The paths starting from here and ending here are still pending. So now you need to do the counting for C2, C3. So it will be 2 into this leftover. That is also done. So guys, it's just a child's play. Let's say y1, y2. Let's say a black node is there, and then there are children. Okay, like child 1, child 2. Every child is having their subtrees, right? Child 4 and child 5. Every child is having its subtree, and you know the size. All are white, baby. All are white. Girl, bro, everyone, listen. All are just white. Yeah, I said like I did not spell it correctly the previous few words. Funny, but no problem. So guys, if it's like that, can you tell me, if you have this array of the sizes y1, y2, y3, y4, y5 the sizes, what will be the total number of valid paths? Start writing it mathematically. Y1 into y1. All the nodes of y1 subtree will have to make relationship with this now. Can you feel it or not? You have feelings only for the girls. The day you bring feeling for the question, you will just propel forward. So y1 into y2 plus. So have feelings for question, not just for girls and crush. Guys, after this, what term I will write? this you can do easily, yaar. Like this you can do in O of n time if n is the size of this array. So once you have calculated this y1, y2, y3, y4, y5, answer is y1 into this plus write in the Google chat. I know this is an interesting problem going on. What will be the next term? एक तो y1 का रिलेशन बना दिया y2, y3, y4, y5 के साथ ये लिख के. अब दूसरा रिलेशन कौन से बाकी है? All the paths which are going from y2 subtree to y3, y4, y5, y2 into correct. Belly Boina understands it. They really understood too. Okay, what about others? I don't know. So next term will be now Karandeep will write the third term y2 into y3 plus y4 plus y5 is the second term. Guys, what will be the third term? Think about it. You can do it. You can do it. You're Kumar ke student. It will be y3 into y4 plus y5. Then it will be y4 multiplied by y5. I think that's it. Y3 into y4 plus y5, then y4 multiplied by y5. That's it. It's done. It's done. Okay. Okay. Aditya Shandilia has given a n square algorithm. Guys, is there any better algorithm than n square to calculate this for an array? Write yes if you think and write no if you don't think so. क्या अगर ये चीज हमको कैलकुलेट करनी है, समझे एरे दिया होता आपको y1 y2 y3 y4 y5 से, तो क्या ये करने के लिए n स्क्वायर एल्गोरिथम चलाना पड़ेगा? n स्क्वायर क्या है? That you take this element, then you again travel the rest of the 5 elements and calculate their sum, then you get this two sum and this three sum. No man, अरे चिल मारो ना, पूरे एरे का सम टोटल में स्टोर मारिए, ठीक है? ज्यादा दिमाग मत लगाइए. पहला नंबर क्या आया? y1 ना. So y1 into total minus y1. Total minus y1 is nothing but the rest of the numbers sum, right? y2 पे आएगा तो you can maintain the sum of first two numbers. So y1 plus y2 multiplied by dot minus y1 plus y2. अरे डन है, तो बच्चों वाला नए नए पैदा हुए बच्चे कर सकते हैं इसको. Anyways guys, it's clear. When I'm saying पैदा हुए वाले बच्चे कर सकते हो, सच्ची में वही बात बोल रहा हूँ. Yeah, yeah. Okay, so you guys understand O of n and all those things. Okay. So guys, everyone write visualization in the Google chat if you guys understand that just for explaining purpose I showed you the children. It will the same theory will apply on the parent also. Let's say there was only one black node. Okay, this is a child, white, white, white. Now its parents are also like that only. Now what is gonna happen? Let's say this was the root node. Can anyone tell me what will be the array getting created for this black node? This children subtree size is what? 3. Now this is not a children, but whatever is the upper part, you can call it the upper branch, na? Upper branch of white nodes, what it is? 2. So you have to run the algorithm on this. Because whatever the relationships are getting formed from here to here, like whatever the paths will be coming from this tree to this path, they will always be having exactly one black node. And that's very good thing. Clear guys? I hope it's all clear, right? Guys, only Aditya Shandila wrote 3 and 2. What about other people? Did you guys understand? Thank you, Sushant Nair. I know you are feeling very good about it. That's why I like to take session. Okay. But what I don't like is that people only come to my session only. You need to go to other people's session also. Yeah. Yeah. So now listen to me carefully. Okay. Mm-hmm. Now, guys, listen. We have only solved the part when there is only one black node. Okay. So don't be very happy. Okay. You can be happy. Why not to be happy? Only one life, right? So yeah, let's assume just only one black node in the tree, and then it's all its branches. You just go and calculate, and their sizes you just somehow calculate, and you just do the BFS and just calculate the array and just multiply, and your job is done. Okay, job is done. Okay, what if there are multiple black nodes? Once this is solved, the problem is done, right? No. We don't. Yes, Ajinkya, we can assume B is rooted. Great job, great job. But we cannot assume that because in the actual problem there can be multiple black nodes, right? So let's throw that assumption. Okay. So guys, think about it. What to do if there are multiple black nodes? It is also easy. I will tell you, it's very easy. White, black, white, 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 black, white. Okay, great. white, black, white, white, white. So you know what? We are trying to calculate the paths where there is exactly one black node. Okay, but we can fix na those paths have which black node because only one black node is possible. So guys, do you understand that each path I to j which is valid, any valid I to j path will always be unique. It will only consist of a particular black node. So you can calculate the unique paths for each and every black node. That's the solution. अरे वैलिड पाथ क्या होता है? वो होता है ना जिसमें सिर्फ एक ब्लैक नोड है. तो वो एक ब्लैक नोड हर बार अलग अलग होगा ना. समझे बात को? एक एक ब्लैक नोड के लिए यू कैन कैलकुलेट ऑल द वैलिड पाथ्स एंड दे विल नेवर इंटरसेक्ट विद ईच अदर. दैट्स द नाइस थिंग. So guys, there are how many type of paths possible? There are how many black nodes? 1, 2, 3. So guys, there are 3 type of paths possible. You will calculate all of them and you will add them. So how will I calculate type 1 paths? How will I calculate those paths which have one black node but this is the black node which they want to travel with? What will you do for this? Simple trick. You will run the BFS from this node. Okay, run BFS. You have started traveling. Go travel, 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 travel. As soon as you see a B, stop and break this in your head. Break this. B, start traveling from B and go to all the white nodes. As soon as you see another B, break this. Now guys, this new tree has formed for this black node. Can you see it? Wow, interesting. Congratulations. Now guys, this is again the same problem. मैंने तुम्हारे लिए इजी कर दिया. जब भी कोई ब्लैक नोट दिया है ना, तो वहां से ट्रेवल करो और ढूंढो बाकी जगह ब्लैक कहाँ आ रहा है. काट दो उनको, काट दो उधर, पाट 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 काट दो. काट दिया, बहुत मजा आया. अब सुनो, after cutting is done, you will get a tree which has only one black node and you know how to solve it. Don't ask it to me. जब जो अभी नया ट्री निकला है बेटा, उसमें सिर्फ एक ही ब्लैक नोड है. तो आपको पता है उसके जितने भी नेबर है, सबका जा जाके सबका अलग अलग. सी देयर कैन बी सो मेनी ब्रांचेस. 1 ब्रांच, 2 ब्रांच, 3 ब्रांच, 4 ब्रांच, 5 ब्रांच. आपको पता है सब वाइट है ना, तो सारे ब्रांच में जाके बीएफएस करो और गिनो कि उधर कितने नोड्स है और बना दो अपना y1, y2, y3, y4, y5. हो गया काम, डन. So you are able to calculate all the simple paths where there is only one black node and that black node is this node by the way. That black node is this node by the way. So guys, you are able to calculate T1 by doing BFS on this black node. Can anyone tell me how to calculate T2? Let's say this is the black node. I want to calculate the number of valid paths which have only one black node, but that black node should be the black node number 2. What will I do? Let's see what the people have written. You will do BFS on B2, right? Just do BFS on B2, right? Right? Yeah. Maza aa gaya. Okay, thank you. So guys, can anyone tell me how does that look after the black node? Yes, good Aditya Shandilya. How does the node, how does that look like after that is done? Can you just imagine and tell me? How will the tree look like? I will start traveling from here. All white, white, white. I'm liking. Black aate cut. Acha guys, can anyone tell me why am I cutting black aate? Because अगर if you are trying to calculate the paths for this black node, तो एक ही black node चाहिए ना. दो आते ही गलत हो जाएगा ना सब कुछ पाथ में. तो काट ही दिया उसको. कट. Don't travel ahead. आगे जाने का मतलब ही नहीं है. This is the new tree coming up. Guys, can you tell me for this new tree what will be the array if you try to create for this black node? See all the neighbors and try to calculate their subtree sizes. Okay, so this neighbor has 2 nodes. 2 and this neighbor has 1. 2 1 1 1 2 1 1 1 1. This will be the array coming out if you're trying to calculate all the valid paths which are you're trying to calculate all the valid paths which are having a single black node, but this should be the black node. This is what you do. Clear? Now guys, tell me what to do to, like, you know, to T2. Now tell me what to do for T3. T3 guys, T3 is start traveling. Break up has happened here only. Guys, can anyone tell me the final array which will come for this? Finally, you will always get a tree which has only one black node and all others are white. So you just have to go to the neighbors and you have to check what are the subtree sizes of those neighbors. The neighbor can be your children, then it's very easy, right? Neighbor might be your parent, so be a little careful. ठीक है, तो कोई बड़ी बात नहीं है, जितने भी नेबर है ना, हर नेबर का बीएफएस चला दो ट्री ब्रेक करने के बाद, हाँ पहले नहीं तो हर जगह बीएफएस चलाओ, टोटल नंबर ऑफ नोड्स तो पता चल ही जाएगा, बीएफएस चलाओ, डीएफएस चलाओ, जो चलाना चलाओ. So it will be 1 comma 1, right? 1 comma 1, something like that, right? So it will be 1 comma 1. So you guys have understood these things, right? It'll calculate all the answers. But guys, write in the Google chat, careful, 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 careful. We forgot to count some other type of paths. Let's say this is black node, this is white, this is white. I know no one is going to teach you such in-depth things. No one, no one. It requires lots of passion and lots of patience. Now listen to me, baby, listen. Black, white, 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 white. Okay, okay, okay. So what are we doing here? This subtree 1. Guys, please tell me the subtree. Make the array. Guys, fast. 2. 1, 2, 4, right? This is the array, right? Right, guys? Yeah, so someone is saying 1, 2, 2. सुमित कौन से दुनिया में हो आप? इधर हम लोग अर्थ पे फिलहाल. 1, 2, 4, 1, 2, 4. 1, 2, 4 है सुमित, 1, 2, 4 है. दिखना चाहिए आपको, ये देखो. इधर एक, इधर दो. और इधर 4 है टोटल ये सब ट्री में. जो ये ब्रांच से जब भी कोई ब्रांच निकलती है ना, तुमको देखना है वो ब्रांच के अंदर टोटल कितने हैं. ऐसा होता है. नहीं आता तो ट्री कोर्स करो. So guys, this thing also you know, right? It's all going good for you, right? 1, 2, 4. Sumedh, write 1, 2, 4 if you understood this. So guys, you are just calculating what? You are calculating 1 into 2 plus 4 plus 2 into 4, right? Yes, sir. If you all agree that we are doing just this much for now. But guys, there are some more paths which we forgot to count. These only count those valid paths which start at white, and end at white. But guys, there can be paths which can just end at black or start at black. We just forgot to count all the paths which start at black basically. So that is very simple na. You just need to know what is the sum of this. What is the sum of this? 4, 5, 6, 7. You have to add 7 in the end. Why? Because from this black node you can travel this white one path, from this black node this white one path, this black, this white one. You have to count the paths from all the paths generating from this also na, black one. अभी तक जितने भी हमने paths गिने थे I to J, they were of such way such that it was coming from some subtree where white node was there, and it was ending at some subtree where white node is there. It was always white to white. White to black and black to white paths we did not count. So it is very simple. The total number of white nodes is the number of paths which will start with black color or end with black color, baby. So in the end, you need to add the sum of the array also just to be safe. Yeah, size of the tree minus 1, not subtree, Ajinkya. So guys, right? Yes, sir. If you have understood the total count feature, total count feature is first you calculate the answer for this, and then add the sum of this also in the end. These things you have understood. कोई लिखा नहीं कुछ गूगल चैट में, पता चला कि नहीं चला? ये सो गए हो आप, बताइए. नहीं नहीं मिस होता. यू आर कुमार के स्टूडेंट, कैन नॉट मिस इट. जब मैंने नहीं मिस किया तो आप कैसे मिस कर सकते हो? सो गाइज, दिस इज इट. ओके, now as per our algorithm, can you tell me what is going to be the time complexity? So we have written so many things that I will just write here, watch the video. Do as like, for deep explanation, watch the video recording. Okay, now time complexity is what? It is O of n square. Still n square. Why? Well, for each black node you are doing the BFS and trying to get it right. So there can be many black nodes, right? So even if let's say n by 2 nodes are black, so n by 2 times you will do O of n BFS, right? So n square by 2, right? So in the worst case you'll just write n square, right? So guys, tell me the time complexity. N square you have written. Only Ajinkya has written. What about other people? Other people also have to write it. Do you guys understand that because you are doing because we are doing BFS from each black node. These are basic things. When you do BFS, now do it smartly. First, you calculate all the neighbors of that black node, which are white in color. Then do BFS from each of those white nodes. And when doing BFS, mention in the BFS that it should not visit the earlier black node or any other black node for that matter. So you exactly get the best subtrees for yourself and your life stays awesome. Okay, so even after doing all this tam jam, we come to know that is n square. Okay, fine. So, what is the optimization? Well, optimization is kept for the next session, but I will give you hints for it. Okay, it's pretty simple. Now, listen. First of all, we will do DP on trees. Why? Because you know where the problem is coming up, guys. Do you know where the problem is coming up? Let's say a big freaking tree is given to you. A big freaking tree is given to you. Nothing actually matters, right? If this node is black, by using some DP on tree, you can always know the valid sizes of the children subtrees, right? You can know like DP of this child can tell you how many continuous white nodes are there in this branch. For each of the children, you will always know the perfect component sizes, right? If this node is black. What will you do for the parent big component coming up? This is very difficult. And in competitive programming, we call it as upward tree DP, which has not been taught to you. So if we put the normal DP will automatically calculate everything efficiently at the bottom. No need to do BFS anywhere. Because if like you will be going from bottom to up, you know the bottom to up terminologies I taught, right? So if some node is white, you will say that DP of this value is 1. DP of this is what? 2. Current node plus the white value below. So if this is white, and there might be many more whites like this. DP of this node is 1, DP of this node is 1, DP of this node is 1, and this is also white. So answer will be 1 plus summation of children, right? So the total white size will become 4. If this node is black, then DP of I 0. So children का DP निकालना कोई बड़ी बात नहीं है. Upward DP में थोड़ा दुख दर्द होगा. Once that is done, the optimization will be done. So that is that kind of problem this is. So once all that is done, DP on trees plus I call it as upward tree DP. And that's it, guys. That's it. So we are going to discuss that in the next session. And one more thing is that in this similar type of problem we were doing in Uber SD interview problem. That time also we left the part where we had to do the upward tree DP. So I think we should cover that also. Okay. So